So we're on the last section of chapter 8, solving rational equations and inequalities. We'll do inequalities tomorrow. Today it's just rational equations. And what is a rational equation? A rational number is a ratio, which is a fraction. So we're talking about equations that have fractions in them. Okay. How do we solve fractions that have, or how do we solve equations that have fractions in them? Well, one way is to get rid of one fraction at a time by multiplying everything by the denominator of that fraction. Bless you. Or you could multiply all get rid of all fractions by multiplying everything by the LCD. So I want to explain both ways, and you need to choose which way you feel more comfortable with. All right. I recommend everybody copying down this equation: 3/4 x minus 1/12 equals 1/8. And I'm going to get rid of one fraction at a time in no particular order. As a matter of fact, I want to ask you, which fraction would you like to get rid of first? Anybody, pick one. The what? Okay, you want to get rid of the 3/4? Let's get rid of the 3/4 by multiplying everything by the denominator of that fraction, which in this case is 4. So put times 4 right there, times 4 right here, times 4 right there. And you will see that the 4's cancel out. Now, right here doesn't necessarily cancel out, but you could reduce, right? The 4 and the 12, that's 4/12, so you could reduce by 4, right? So, I mean, you don't have to do that. You could also multiply by 4 and you get 4/12, which you'll be able to reduce anyway. But I'm going to reduce right now 4 and 12. You'll get a 3 left over in the denominator. So, and the last fraction over here, 1/8 times 4, the 4 and the 8, you could reduce by 4. Cancel, cancel. You get a 2 left over in the denominator. So what do I have left? I have a 3x. That one was easy because I multiplied by 4. That canceled out the fraction. You just have 3x left over. Now I have minus. I still have a fraction. I have a 3 down here. Up on top, I have a 1. And over here, I also still have a fraction, 1/2. Do you understand what I just did? Yes. Okay. Now let's get rid of the other fraction. Which one would you like to get rid of? The 1/3 or the 1/2? It doesn't matter. We're going to get rid of both. 1/3. Okay, so multiplying by 3, that'll get rid of the 1/3, but you got to multiply everything by 3. This by 3, and even this fraction by 3. So the first term, 3 times 3x, that'll give us a 9x. Over here, these 3's canceled out. You end up with a nice, beautiful -1 left over. And over here, 3 and 2 don't cancel, so I actually have to multiply. 3 times 1 is 3. And it is still over 2. So now for my third fraction, multiply everything by what to get rid of that third fraction? 2. Times 2, times 2, times 2. And here we go. We end up with 18x. 2 times 9 is 18. 1 times 2 is 2. And these guys over here cancel out, leaving me a 3 left over. And now I got rid of all 3 fractions one at a time. Very straightforward. I recommend, actually I prefer this method. It's faster to get rid of it with the LCD, get rid of all 3 fractions with the LCD, and you'll see that in a bit. But right now, just to finish off this equation, plus 2, we're going to end up with 18x equaling 5, dividing both sides by 18. You're going to end up with the answer x equals 5/18. Okay. So that's one option. It's very straightforward, getting rid of one fraction at a time. Now, you guys told me to pick 3/4 first. If for some reason you guys would have told me to cancel out the 12s first, it would have actually canceled out 2 fractions. It would have been a little easier. But either way, when you get rid of one fraction at a time, it's pretty straightforward. Multiply everything by the denominator of the fraction that you want to get rid of. Okay? Let's go back to the same equation. But in this this time, I'm going to get rid of all 3 fractions at the same time by multiplying by the LCD. So what is the LCD of 4, 12, and 8? 12. Is it?
No, it's 24.
24. There you go, 24, right? Now, if you struggle with finding the LCD, especially when it comes to variable expressions, you probably just want to get rid of one fraction at a time. But if you're good at finding the LCD, like, okay, check out how fast this will be. Times 24. Times 24, times 24. Now, why am I multiplying everything by 24? Because the LCD is 24 in this case. So multiply by everything by the LCD and watch what happens. 24 over 4, 24 divided by 4 is 6. And 6 times 3 with an x will be 18x. And then over here, 24 divided by 12, that will be 2. And of course, 1 times 2, actually it's a negative 1 times 2, that'll give you a negative 2. And last but not least, 24 over 8, 24 divided by 8 is 3. And 3 times 1 is 3. So you have the same equation. You're going to solve it the same way, add 2 to both sides, and you'll end up with 18x equaling 5, giving us the same answer as before, x equals 5 over 18. A lot faster to get rid of everything at the same time by multiplying by the LCD. However, there is probably more opportunity for mistakes, I think, because it could get a little complicated finding that LCD. Let's take a look at some problems that you're going to see on the homework today. On Google Classroom, on the homework, it shows the assignment for today and tomorrow. Today we're working on just the equations, and I want you to do the even ones at least. Of course, you could do all of them if you want, but I want you to do number 1 and then jump to 2, 4, 6, 8, all the way to 24, skipping 10 and 12. Tomorrow we're going to do a little intro on solving inequalities instead of equations, and then you could go back and do 7, 10, 11, 12, and 13. So today, let's start with number 1. So we could get rid of all 3 fractions at the same time by multiplying everything by the LCD, or we could just get rid of one at a time, right? What do you guys say?
LCD.
LCD? Okay, what is the LCD?
4.
Okay, I could change the 2 to a 4. Okay, that makes sense, but could I change the x to a 4? So what is the LCD? 4x, 4x, right? Okay, you know what? Because we didn't all see that LCD right off the bat, I'm going to show you how easy it is to just cancel one at a time, right? So pick an equation. Pick a fraction, I'm sorry.
12x.
Okay, and you know what? I'm going to go with the bigger, the 4. So you could see that sometimes you'll get lucky and it'll be a lot faster. Look, multiply by 4, multiply by 4, multiply by 4. You could have multiplied everything by x, you could have multiplied everything by 2. But if you picked 4, it'll actually work out very, very nicely. Check it out. The 4's cancel. You end up with a nice, beautiful plus 3. Over here, obviously, 4 doesn't cancel with x, so you have to actually multiply. 4 times 12 is?
46. 36.
48, and it is over x. Okay, and then over here, it actually does cancel, right? 4 over 2, 4 divided by 2 is 2, and 2 times 3 is 6. Or you could have said 3 times 4, what's 3 times 4? 12, and what's 12 divided by 2? It's still 6. So it doesn't matter which way you do it, you're going to get a 6 right here, and the fraction canceled as well. So I didn't even think about an LCD, and I luckily canceled out 2 fractions. All we need to do is cancel one more fraction out. So what do I multiply everything by? X times x times x times x. Cancels, we end up with a 48 plus 3x equals 6x. How do I solve this thing? Subtract 3x, move it to the right. I will end up with 48 equaling 3x. Final step is to divide by 3, giving you the answer, x equals 16. 48 divided by 3 is 16. So that's my answer, and I'm pretty confident that I have the right answer. I don't think I made any mistakes. Now, if for some reason, so that's why I say it might even be more straightforward, more easier to solve it just by getting rid of one fraction at a time, right? But of course, if you wanted to, you could have multiplied all 3 fractions by 4x, and you would have gotten rid of all 3 at the same time, but it could get a little confusing to some of us. So anyway, if you have a lot of time left over, or you're bored and you want to just double check your answer, you could plug in 16 right there. 12 over 16, it'll reduce by 4. Then you'll be able to add it to 3/4, and then it'll reduce down to 3/2, and it'll be a true statement. Anyway, let's move on. How about that guy right there? So this time, it's even easier. I only got 2 fractions instead of 3. So let's get rid of one of them at a time. Which one do I get rid of? You want to get rid of the x over 2? Let's multiply everything by what? By 2, right? By 2. I mean, that's if you decided to get rid of this one first. If you would have decided to get rid of this one first, you'd multiply everything by the binomial x minus 1, which is totally fine also. I probably would have started with this one, but somebody said get rid of the x over 2, so I'm going to get rid of the x over 2. Anyway, obviously this 2 will not cancel with that binomial, right? So I actually need to multiply 2 times x, and that will be 2x. And of course, it's still a fraction, still over x minus 1. And right here I have a negative 1 times 2, or a minus 1 times 2. That's going to be a minus 2. I have an equal sign, and of course these guys canceled out, so I have a nice beautiful x on this side. So I got rid of one fraction. Let's get rid of the other. What do I do?
Multiply everything by x minus 1.
That's right. Multiply everything by that binomial, the denominator, x minus 1. And when we say everything, we're talking about everything. That minus 2 times x minus 1, and even the x times x minus 1. Okay? So, of course, right here, it's easy, it's beautiful, it cancels out. You end up with a nice, beautiful 2x. Right here, it might get a little tricky. It does say minus 2 times this binomial. So the minus, I'm going to include it like if it were a negative 2, all right? Negative 2 times x, that'll give me a negative 2x. And then negative 2 times negative 1, that'll give me a positive 2x. No, positive 2, not x, I'm sorry. And now on the right side, we're going to distribute x times x, that's x squared, and x times negative 1 is negative 1x. So we got rid of both fractions. Now all we got to do is recognize that this is a quadratic, it's an x squared, right? Quadratic equation, and we need to remember from the past how to solve quadratic equations. Well, you want to set it equal to 0. That way maybe you could factor, split, and solve. And if all else fails, if you can't factor, you could always use a quadratic formula. X equals negative b plus or minus square root of b squared minus 4c divided by 2a. Okay. Let's set it equal to 0. And you know what? Even before setting it equal to 0, I'm noticing this is a 2x right here, and this is a negative 2x right there. I could just combine those right now. That and that will cancel out. Disappears. So all I really need to do is move this 2 over to the other side by subtracting it. And what I have is 0 equals x squared minus 1x minus 2. And right here we have a quadratic trinomial. Your a value is 1, your b value is negative 1, and your c value is negative 2. So if you wanted to, you could use a quadratic formula because set equal to 0 to solve to get your 2 answers. But I would always try to factor first. And you can put the set equal to 0 on this side. So what times what is negative 2 that if I combine together is negative 1? Positive 1 and negative 2, right? Okay. And now that it's factored and it's set equal to 0, I hope we remember 0 product property, which says that when you have something times something equals 0, the first something could be set equal to 0, the second something could be set equal to 0. So we're going to do exactly that. X plus 1 equals 0, x minus 2 equals 0. Your 2 answers will be x equals negative 1 and x equals positive 2. So those are the 2 answers to this rather long equation. Now, I do need to mention something that I didn't mention on the previous question. Whenever you get answers and you have variables in your denominator, you want to take a quick second and make sure that your answer doesn't cause it to become 0. Because if you have a 0 in the denominator, it's going to be undefined, and that'll mess everything up, okay? So for example, if this answer would have said x equals 1, and then the other answer x equals 2, and if I plug in a 1 right here, it doesn't say 1, it's a negative 1, but if it were a positive 1, let's pretend, if I plug in a positive 1, it'd be 1 take away 1, which is 0. That would make this 1 an extraneous solution. I wouldn't include it. I would not include it. But because it's negative 1, it doesn't make it 0. Negative 1 take away 1 is negative 2, and you're good to go. All right? So both of these are your answers. Let's take a look at, let's say, number 4. Why not? So right here we have 2 fractions, and luckily they both have the same denominator, so I'm going to get rid of both of them at the same time by multiplying everything by s plus 2, the LCD. Oh, yeah, the common denominator, s plus 2. So s plus 2 right there, s plus 2 right there, and s plus 2 right there. Obviously, s plus 2 binomial cancels with this binomial, s plus 2. Over here, this s plus 2 cancels with that s plus 2. The only real math I have to do is this guy right here, the positive s. I want to call it a positive s because if it were a negative, I would definitely have to call it a negative s. But it has a plus sign, I want to call it a positive s. Positive s times s, that's a positive s squared. Positive s times 2, that's positive 2s. And this first fraction disappeared. We have a regular s, so I'm going to bring down that regular s. And then we have the equal sign. And over here, this fraction disappears. I have a 5s plus 8. 5s plus 8. So from here, we're going to move everything to one side. We're going to combine like terms if we have anything to make it to combine. We have an s and a 2s. That's going to be a 3s. So what we have is s squared plus 3s equals 5s plus 8. And we might as well, I want to move everything to the right side. So subtract 5s, cancels. Subtract 5s, that will be s squared minus 2s equaling 8. And finally move over that 8 by subtracting 8, So we will have s squared minus 2s minus 8 equals 0. Are you with me? Now this quadratic trinomial that's set equal to 0, I want to rewrite it up here. S squared minus 2s minus 8 equals 0. I know that I could possibly factor it because the a value is 1. So all I got to do is think what times what is c that if I combine together is b. And of course we have s's right here, not x's, we have s's. So what times what is a c value that if you add together is a b value? 2 times 4. Which one's positive, which one's negative?
The 4 is negative.
The 4 is negative and the 2 is positive. So that is factored. It's still set equal to 0. I could now apply zero product property to split them and solve. I'm going to take both of these denominators, split them, and set them each equal to 0 and solve. So I have s minus 4 equals 0, s plus 2 equals 0. That will give me two answers. S equals positive 4 and s equals negative 2. Now, if you put those two answers on your quiz, you're going to get it wrong. What? Why? Because remember, you got to take 1 second and make sure that when you plug in your 4, you don't end up with the 0 in the denominator. Okay, that answer is great. So this answer for sure, s equals 4. But this answer, negative 2, when you plug that in right here, negative 2 plus 2 is 0. And if you divide by 0, it doesn't matter what you have on top. If you divide by 0, the answer is undefined. So what does that mean? That means that this guy is not an answer.
So you only put the 4?
So you only put the 4. Okay. Technically, the s equals negative 2. That's what we call an extraneous solution. That just means that it's an extra answer that doesn't work. You don't have to write that. I mean, on the test, all I'm going to ask is for you to write the answer, and you're just going to write s equals 4. If you put s equals negative 2 as well, then it's going to be wrong, because negative 2 is not the correct answer. Because if you do plug it in, it's undefined. What do you think?
Pretty cool.
Pretty cool, pretty easy. So again, this whole lesson is all about getting rid of fractions. Like this guy right here, multiply everything by y minus 5. This guy right here, get rid of one of the fractions at a time, multiply by x, then after that, multiply by 3x minus 2. We will have some inequalities, but we're going to wait on these inequalities till tomorrow because there's a couple of extra steps. I want to go for a more challenging question. Let's say this one's going to be very interesting, number 22. Before doing anything, what's the very first thing we do on all of these sections of chapter 8? We have a fraction and we wanted to simplify it. What would we do first before trying to cancel things out? Factor. So just like what we've been doing this whole month, we're going to continue to try to factor anything possible. So the only thing I could factor is this guy right here. I'm going to rewrite that as x plus 2, x minus 2. Everybody knows that, right? Okay, so I don't have to look at this anymore. I already rewrote it in factored form. And you know what? This guy looks a little out of order. So I'm going to switch things up. I'm going to rewrite that as a negative x plus 2. And then not only that, I don't see any of the other ones with negative x's, so I'm going to factor out a negative 1 as well. So I'm going to factor out a negative 1, And that will leave me with an x minus 2 left over on the inside. Does that make sense? Okay. So I don't have to look at that or that. There's my new factored denominator that's in order. Okay. And you could try factoring the top, but you can't because of the plus sign. If it were a minus sign, for sure, you could do x plus 2x minus 2. But it's a plus, okay. So anyway, let's get rid of some fractions. Which one? How about this? Pick a fraction that you want me to get rid of. The first one? Okay, if I want to get rid of this first fraction, I'm going to have to multiply everything by the denominator of this fraction, which technically means both binomials, both binomials, both binomials. Would you like to do that, or does that sound a little... it could be a little easier if we get rid of this one first, because then you'd multiply by x plus 2, x plus 2, and x plus 2, right? So in math, you're always going to look at all your different roads and go for the most comfortable path, right? Unless you're like in a rush, then you go for the quickest path. So in this case, what do you guys want to do? You want to get rid of this guy by multiplying everything by both binomials, or do you want to get rid of one of these or one of these? The last one? Let's get rid of that last one by multiplying by x plus 2, x plus 2, x plus 2. Now this works out pretty great because that x plus 2 cancels with that x plus 2. I end up with just 2 left over. And then this x plus 2 does not cancel with that x plus 2 because it's an x minus 2. But up here, this x plus 2 does cancel with that x plus 2. Bless you. So that cancels with this. And what do we have left? We have x squared plus 4 up on top over x minus 2. And then the second fraction, we have still a fraction. That negative 1, I could leave it down. Yeah, I'll leave it down there for now. Negative 1, parenthesis x minus 2. But up on top, I have x times x, that's x squared, and x times 2, that's 2x. It's probably one of the most challenging questions on this homework. So let's get rid of another fraction now. Which one? The left one or the middle one? Left one. Okay, so I'm going to multiply by x minus 2 to get rid of that x minus 2. But I need to multiply everything by x minus 2, including this 2 by x minus 2. So beautifully, it cancels. We end up with x squared plus 4. Over here, the x minus 2 also cancels. That's very lucky, because now we don't have to distribute it up on top. So I end up with a okay, this is where it gets a little confusing. These two terms divided by a negative 1, each of those will be negative. Does that make sense? Or no? Or how about this? How about this? I want to take the negative 1 and I want to put that as a negative sign right here. Yay or nay? I'm hoping that this makes sense, right? You just have a negative 1 left over. If you divide anything by negative 1, nothing changes except for the signs. So, I don't know. I guess I would just say, what's x squared divided by negative 1? That becomes a negative x squared. Maybe I'll just do that. Negative x squared. And what is 2x divided by negative 1? That's also a negative 2x. Are you with me? Equals 2 times x, 2x, 2 times negative 2, negative 4. There's my equation. It's huge, it's long. Let's combine like terms, make it a little nicer. Let's simplify it. When I do x squared, take away x squared, what do I get? 0, cancels out. Okay, that's awesome. And then when what could I do next? Let's move the x's to one side and the numbers to the other side. So when I subtract 2x, I'll end up with a negative 4x. And I'm going to bring down the positive 4 that's in front of it, equaling a negative 4. And then we would subtract 4, giving us negative 4x equaling negative 8. Final step, you get rid of that negative 4 by dividing by negative 4, dividing by negative 4. Get our final answer, x equals positive 2. But, and that's a big but, we need to do what with that answer?
Plug it in.
Plug it in to make sure that you don't get what in the denominator? That's right, because that would make it undefined. So if you take the answer 2, plug it in right there, do you get 0? But when I plug it in here, do you get 0? Yeah. That's not good. Even if I plugged it in over here, 2 squared is 4. 4 take away 4 is 0, which would make these undefined. So what does that tell you about this answer? It's extraneous. So what is the answer to this actual question, number 22? No solution. No solution. Yeah, technically the equation is undefined. We're just going to say no solution. And on the practice test, I think we'll have one of these, and if the instructions say if it says no solution, you could type in n.s like that, or you could type in no solution or abbreviate no sol. But anyway, I don't know. How do you guys feel about this? Should we do another, or are you guys ready to rock and roll on your own?